So the control itself, the Arduino inside of it, can take anywhere from 5 to 12 volts of power to run it, and these cells are anywhere between 4.2 and 3.2 volts full or dead. So basically I'm going to pick any two cells, and run the Arduino on 2S power. That should be somewhere between 8.5 and 7.5. No, sorry, 6.5. 8.5 to 6.5 volts, which is fine for the Arduino. The happy coincidence is that this power will also be running the voltage gauge, so I'll be able to kill two birds with that one stone. Literally just pick any two of these. That black mark denotes negative on this side. So probably going to use that one. And if I wanted, a single cell, would be those two side by side. I actually want 2 cells worth of power. So I'm going to do this wire, skip a wire, this wire, grab my power off of this, run it into my QS10 connector, which coincidentally has these pins, 4 of them. I'm going to be using 2 of them, and that'll seal up. And then on the motor itself, use the 2 appropriate pins to get power from there into the paramotor. That way this all comes apart on one connector. Wire connected, spiraled around the positive cable and attached to those 2 pins. Move on to the paramotor. And now we begin a really cool coding montage. So now to the hoop section. I don't know why it didn't occur to me, but this whole meshing stuff would probably only hold up to 1 strike, and it looks terrible. It's just, kind of peeling all over the place. Not very well thought out. So I reached back out to CNC Madness, the people who made the arms the first time, and got them to make some 2mm plates to go between the spars. So I'm just gonna cut all this crap off and put those plates on instead. It's going to be a lot more durable, look better, and certainly protect better. Oh. Okay. The code here is pretty extensive. If you know Arduino, I guess it's probably not that complicated. But these are all the setup bits. This prints the text onto the screen. And we've got the variometer printing onto the screen, the altitude reading, printing the altitude, checking the battery, printing how much battery we've got left, specifically doing variometer calculations. And this is run once every, I think it's 5 seconds, or sorry, 5 times every second. Checks the battery again, checks the gyro, if it's twisting, turn off, and then all of this down at the bottom for figuring out the speed controller junk. It's a bunch, but it's here. So let me show you how this works. I still have to fix the AGL. I know it's wrong. I'm just getting there. So we're gonna unplug, turns everything off, plug it back in, make a fresh start. So you set your throttle to the low position, and then set throttle to the high position, and then release throttle so that it doesn't run away on you. And the whole point of that is to calibrate every time, so even if it's a little different, it won't go crazy. So as it sits here, basically have a dead space so that it's not triggering, tripping out all the time. And yeah. Pretty smooth throttle. It's tricky because everybody likes electric for the immediate response, but you don't want it necessarily for the sudden swing, the lunge. So basically what I've got is every time I pull the trigger more or less than what it was last time it checked, it divides the difference by 5. So it takes 5 cycles, basically right at a second, to actually increase to the amount that I pull or release to. Which smooths it out and keeps the whole thing from shaking off the table here, but again. And hopefully that'll put less wear on the props, but yeah, that's pretty impressive, I think.